Hello everyone. The purpose of this video for CSC 120 or CIS 115 is to help you understand how while loops in particular can be used to process input and to validate input. I'll switch over and share my screen. So here on the checklist for Module 4, you'll notice there's an item that says, for help with CodeLab input testing questions, please carefully read and run the input testing with while loops material. So this is a little bit of textual material that I've put out there in the site for the class that gives us some examples. Here's what comes up when I click it. And you can see here that often we want to trap the person that's running the program until some condition is met. Now, there's a pattern to this. If you look, the first thing we do here, where I'm highlighting, is we capture something before we get into the while loop. Now, in this particular example, we're going to continue to loop, trap the person basically until they key in an A, until they type in an A. So let's take this code and I will copy it and I'll paste it into Tawny. There we go. And we'll start a new item here. Okay, so again, I was talking about there's a little bit of a pattern to this. So we capture what we're wanting to test once before we get into the while loop. We test it again at the bottom of the while loop. So this indented area here is the code that's going to get cycled through each time our while loop iterates or cycles, whatever you want to call it. So you'll notice here the last thing is we're capturing that letter again. So we've actually got this code in our program twice. Once before we get into the while loop, and again at the bottom of the while loop. You have to capture it outside of the loop at least once, because a while loop is what we call a pretest loop, meaning that it tests before it ever enters the loop. So a while loop may not ever run at all if it doesn't pass this test. So this while loop is going to continue to cycle until we get an A. Why will it stop when we get an A? Because we said as long as whatever they've typed in is not equal to an A, then we're going to keep looping. So let me run this. I'll make myself a little folder, input testing, and I'll call this input testing demo. Okay, so you can see that it's running and it's asking me to enter a letter or type in an A to stop. So if I type in a W, you can see it just, the loop cycled again. It's sitting down here waiting on me to type in another letter. A Z or two Z's, it still cycles. When I type an A in, a little a, you can see it stopped. So remember that it's going to continue to cycle as long as whatever you put here where I have highlighted is true. as long as this condition is true, it's going to keep looping. Now, here's another example. It says the following loop will continue to loop until the person running the program types in a number between 5 and 9. So if we typed in a 5, the program should stop. If we typed in a 6, it should stop. 7, 8, and 9, it should stop. If we typed a 10, it should continue to loop. If we typed a 4, it should continue to loop. So we'll take this code and we'll paste that into Tani and try it out. So here we go. Okay, so you can see, much like we had with the first example, okay, we have this line in our program twice. Once outside of the while loop, we have to get a number before we can test anything here, okay? So this line is getting a number. Why is it getting a number? Well, our input function that we're calling here returns a string. We wrapped this input function that returns a string with an int function. So this is going to take an input a string, then we're going to convert that string into a number, and we're going to store the result in this variable that's named number. Okay, so we do that once outside of the loop. We do it again at the bottom of the loop. At the bottom of the loop. So you see the same pattern going on. Now, you got to be careful here with your condition. Remember, we said that the loop will continue to run as long as this condition is true. Now, if we typed in a number, it can't be both less than 5 and greater than 9 at the same time. That's why we have an OR. I know that's hard for some folks to understand, but it can't be less than 5 and greater than 9 at the same time. So we have to have an OR. This says if the number is less than 5 or the number is greater than 9, then we're going to keep looping. Okay? So these examples are close to what they ask you to do in CodeLab. So let's go ahead and run this one and see what happens. So here it is. It's sitting on this line right here in the program. Okay, it's asking me to key in a number between 9 and 5 to stop. If I wanted it to keep looping, I could type in a 10. You see it says you entered a 10 and it looped. It's sitting down here now on this line waiting on me to type something in. If I type in a 3, okay, you see it looped again because a 3 is less than 5, right? So we got back into the loop, okay? And it's waiting on us to type something again. And so it's just going to sit here in this portion of the code and keep cycling until it gets something that is satisfying this condition. So let's go ahead and put a 5 in there, and we can make this loop stop. And you see it did stop. Okay, let's go into CodeLab and let's do a few of these input testing items. So we'll get into CodeLab here. And we'll get into one of our classes. And we're looking for module 4 and loop, well, let's see, input testing loops right here. So gonna expand that. And we can go ahead and do the first item, the first item in that input testing loop material. It says, write some code that repeatedly reads a value into the variable n until a number between 1 and 5 has been entered. Now, CodeLab will not allow us to put a prompt. You see what I had right here that was printing this stuff out to kind of explain what we needed to key in? CodeLab will not allow us to do that. So just word to the wise, you can't put anything inside the parentheses of our input. But a lot of this is exactly the same as what we were just doing. Okay, so I'm going to go ahead and copy this. Well, I can't copy and paste into CodeLab. So let me just go ahead and it says the variable is n. So n equals, okay, and it says reads a value into the variable n until a number between 1 and 10 has been entered. So much like what you saw in the example, I'm going to have to take an input function and wrap it with an int. So I have an input inside of an int function. That's going to get a number. It's going to assign that number to n. Okay. Now we need to write our while loop. Let me see if I can make this any bigger. Okay, that's a little bit bigger. Now we need a while loop. While, okay, and it says repeatedly reads a value into the variable n until a number between 1 and 10 has been entered. So we want our condition here to cause us to loop until we get something between 1 and 10. Now there are a couple ways that you could do this. Okay, we could say we could use the same pattern that we used with this one right here, where we have an or, because n can't be both less than 1 and greater than 10 at the same time. That should tell you we've got to use an or here. So remember, our variable is n. So while n is less than 1 or n is greater than 10, that's going to be our loop situation. Now remember, this is a Boolean expression right here where I'm highlighting. You notice I had to list n both times. I have this condition, n is less than 1. I have another condition here, n is greater than 10. Okay? So next, we're just going to repeatedly read a value into n until we get a number between 1 and 10. So actually, all that this loop needs to do is this. Remember, I have this line once outside of the loop. I have this line again inside of the loop. So as long as we're typing in something that's less than 1 or greater than 10, it's going to keep looping. Okay? When we get a number that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it will stop. Okay? So let's submit it. You see I got it right. I'm going to take this code, if I can get it highlighted correctly here. Got that code. Copy it to the clipboard. Going to go to Tawny, and I'm going to paste it in just so you can see it run. Okay? So here we go. And get my spaces fixed and clear this bottom window out. Okay, so remember, it doesn't have a prompt here because CodeLab will count it wrong if you put a prompt in here. So just watch this shell window. There'll be a vertical bar flashing when it's waiting on us down there. Okay, see the vertical bar flashing? Okay, so I'm going to key in a -1. Okay, you see it's still looping. I'm going to key in a -2. You see it's still looping. I'm going to key in an 11. You see it's still looping. Okay, now I'm going to key in a 1. Not a 0, a 1. And you see when I hit enter, it stopped. It broke out of the loop. So that is 51,935. Okay. We can go ahead and do one that seems to give folks a lot of trouble. 51,907 is probably as good of a place to start as anywhere. Let's see. That's actually in our testing input. So we'll do one of these that's a little bit of a trick for folks sometimes. So this is saying write the code to read a value in the area of a square into a variable area of square and print out the length of a side of the square. So remember that the area of a square is just the side squared because both sides are equal of a square. So it's just whatever variable we want to use we need to find the square root of that to get back to a side. Now you can't import the the math library for Python in CodeLab. But what we can do is we can raise something to a negative power. Not a negative power, but a fractional power. So if we wanted to get the square root of this variable right here, area of square, we could raise this to the 0.5 power, the half power, to get the square root. So let's go ahead and input this and see if we can get it to work. Okay, so we're supposed to read in area of square equals, and read it. If any value read in is not valid input, just print the message invalid. Okay, so it's telling us that it's invalid if it's not the square root of a negative number is not real. So anything less than 0.0, I guess, would be negative. So let's see if we can get this to work with an int function like we were doing earlier. Area of square, we'll take an int, and then we'll put an input inside there. What that's going to do is this is going to allow us to key a string in, and then we'll convert it into an integer, and then we'll store it in the area of square. Let's see, didn't say to use an int, so let's try float on it. Okay, let's try float just to see if it'll work. We may have to come back and touch this up. If area of square is greater than or equal to 0.0, we got a positive number there. Okay, we can print area of square, raise something to an exponent is 2 asterisks, and 0.5. Okay, that should get us a square root. Else, we've got a negative number. What are we supposed to do? Print invalid. Let's see if it'll take that. We got away with it. So this is getting the square root right here, raising something to the half power, 0.5 power. Okay. All right, now that we've done that 51907 that seems to give folks some trouble, let's go down and do another input testing loop here. And how about we do, we can go do the bottom one. Okay, let's see what this one says. Write a loop that reads positive integers. So instead of using float like we did on the last one, we'll read in positive integers. Standard input just means from the keyboard. Anytime CodeLab tells you to get something from standard input, they want you to get it from the keyboard, somebody typing it in. If they tell you standard output, they want you to print it. That's when you use a print statement, you send something to standard out. Okay? So write a loop that reads positive integers from the keyboard in and terminates when it gets something that's not positive. So we want a loop as long as whatever we're keying in is not negative. I don't know about 0. 0, I think, would probably be positive in this case. So let's go ahead and try it with a loop considering 0 to be positive. Okay, so we'll loop as long as we're did I say positive? I don't think 0 actually has a sign, so I think we can just use greater than 0. Let's try that. Okay, what are we reading into? Didn't say. So they didn't give us a variable name, so we can just use some number is a good variable name equals int. Why am I using int? Because they told me to use positive integers. Okay, so then I'll do my input inside there. So I have an input wrapped inside of an int. Okay, now this says to get the sum of the even integers and the sum of the odd integers. Okay? When you see the word sum, you should know from looking at the loop patterns last week that when they say sum, we're going to be using the accumulate pattern. Now, when they say only certain numbers, only certain ones, it's a filtered accumulate. A filtered accumulate. In this case, we've got to add both the odd and the even up. So before we ever get into this loop, you need to set your accumulator variable, or your variable to hold the sum or the total, equal to 0. We always do that. So that's the way the pattern was described. Even equals 0. That'll be my sum of even numbers. Odd equals 0. That'll be the sum of my odd numbers. Now we need a while loop. Okay. While some number is greater than 0, we'll keep looping. Now remember, we need to do this again at the bottom of our loop. So I'm going to go ahead and do that. Some number equals int input. Okay. Now this indented area here where I have highlighted is the body of the loop. So we're going to need an if statement for evens, and an if it's not even, it's obviously odd, because a number can only either be even or odd. So if some number is my variable name, if some number modulo lets us get the remainder, if some number divided by 2 double equals 0, what does that say? If some number divided by 2 has a remainder of 0, because that's what modulo does, is it gets you the remainder. If we divide any number by 2 and we have a 0 remainder, then it's even. So even equals even plus 1. Nope, not plus 1. This is the accumulate pattern, so it's going to be even plus some number. Okay? If it was a counting pattern, we would have added 1 to it. Okay, here's what I was saying. Else, if it's not an even number, it must be an odd number. Equals odd plus some number. Okay. And so we have our if-else statement. The last thing that we do in the loop is get another number. Okay? So are we done? After the loop terminates, print out on a single line separated by a single space the sum of the even and the sum of the odd. Okay, so I'm going to outdent, so I'm no longer in my loop, and I'm going to put a print statement here, and it said the sum of the even, and if we put a comma in the print, that gets us a space, and this is going to be the sum of the odd, okay, sum of the odd numbers. So this is my whole program right here. Let's see if we messed anything up. Nope, we got it right. We got it right. So that's the 51940. Okay. We can do one more in here. How about we do, well, we can just jump up and do the one above that. Okay. Now let's see what this one's asking us to do. Write a loop that reads positive integers from standard input. That's the keyboard. That terminates when it reads an integer that's not positive. After the loop terminates, it prints out on a line by itself the sum of all the even integers. So this is pretty much like what we did with 940 here, okay? Except that we don't need the odd part. So this just a little bit less than what we had to do with 940. So we can even use our same variable name if we want to. Some number equals int. Okay, there's my int function. Gonna get a number from the keyboard. Okay, so there's my input function wrapped inside of an int. Okay, remember when we're accumulating something, remember it said sum. Okay, we only need to worry about the even integers, so we can just worry about the even ones. So even equals 0, you have to do that outside of your loop. Then while some number is greater than 0, it said positive number integers, right? Yeah. Okay. Even, let's see, if some number modulo 2, remember, double equals 0. What did that do again? Takes some number, divides it by 2, and gets the remainder If the remainder is equal to 0, then we have an even number and we need to add it up. So even equals even plus some number. Okay? We outdent when we're done with the loop. Excuse me, when we're done with the if statement. So then we need the last thing, some number equals int input. Okay, remember you have this once outside of your while loop before you ever get into the loop. You have it again at the bottom of your loop. Okay, and then what were we supposed to do at the end of the program? On a line by itself, the sum needs to be printed. So when I'm outdented all the way to the left, I'm out of my while loop, and we can print out even. This will have the sum of all the even numbers. Remember, we're only going to add something to our sum of even numbers when it is an even number. Okay? So we got that right. Okay? So there are some pretty hard items here in the while loop section. There are some pretty hard ones, especially down towards the bottom. So you can take a look at these. Let's do, I think we've already done some of these in another video. I'll do this really hard one here. It says, assume, this is 51,253. It says, assume there are two variables, k and m. Okay, they both have positive numbers in them. Okay, they want us to compute the sum, the number, not the sum, the number. So this is just a counting pattern. Okay, it didn't say sum, it said number of. So the sum of the perfect squares, not the sum, the count of the perfect squares between k and m. In order to do this, I'm going to have to loop up until I find the perfect square that is greater than k. So that's going to take one while loop, and then I'll need another while loop to keep looping until I've got all the perfect squares up to and including that number, perfect square. So let's try it. We need two while loops to accomplish this. They did not give me a loop variable to use, so I'm just going to use I, and I'm going to set it equal to 1 because that's where we're going to start, is at 1. Okay? Q is going to have the count in it. Remember, when you're using the counting pattern or the accumulate pattern, you always set your sum or your count equal to 0 before you get into the loop. While I times I, that's going to square whatever number we're on, which the first time we're going to be on the number 1 because that's what we made I. While I times I is less than k. Okay? While I times I is less than k. Okay? I equals I plus 1. Okay? That's going to count up until we get to k. Okay? Or that's going to roll, I guess is a better way of saying it. That's going to roll through numbers until we get up to k. All right? Now that we've got our starting point is set to the right number now after this loop finishes, okay? we can do another while loop. While I times I is less than or equal to, why did I do less than or equal to? M, because it's got to include M in there. Okay, so all right, Q equals Q plus 1. That's our counting pattern. Okay, Q's going to have our count in it when this is finished. I equals I plus 1. Okay, and that should do it. And you can see it did. So we just worked 51 to 53. 51 to 53. See if we can get back over here. Let's do 51 to 52. 51 to 52, starting at the bottom and working our way up. So here's another perfect squares problem. Okay, perfect squares. Except all we have to worry about is just the perfect squares that are less than h. So we have h and we have q. And again, they didn't give us any variable to count with. So I'll just go ahead and use I for that. Remember, when we're counting, our counting pattern says that we've got to set our counting variable, the variable that's going to hold our count, equal to 0 before we get into any loop. I'm going to set I equal to 1. This is going to be what we bump each time through our while loop. Okay, while I times I is less than h. Perfect square, remember, squaring that number. Okay, all right, q equals I times I. The sum. It's not a count, it's a sum. So it's an accumulate pattern, sorry. I times I plus Q equals Q plus I times I. I don't need any parentheses there because it's going to do this first. So this is going to sum up. We're just going to take whatever number we're on, square it, and then add it back to Q. So that's going to take care of our sum. And then I've got to worry about bumping I up by 1 each time. Okay? And looks like I messed something up. Let's see, what does it say? You might want to delete this. Let's go back and see if we can figure out what we messed up here. I've got Q set equal to 0. I've got I set equal to 1. While I times I is less than h. Q equals Q plus I times I. I equals, okay, let's see. Where did we go wrong here? Let's see. And I hit submit or go back to results and see. Consider replacing I with 1. consider removing the asterisks. Let's go back and read this again. Write the code necessary to count the number of perfect squares. Oh, I was trying to sum them up. Okay, so I guess I misread this. I was thinking it was the sum of the perfect squares. It said assign the sum you compute to the variable q. Okay, so count the number of perfect squares. So let's look at the solution here. Q equals, I really don't think that's, I guess because we're doing it right here. Okay, well, let's try that. Okay, so there's 51, 252. This is what I changed, this one line right here, that it was saying I should take out my squaring because I'm doing it here. Okay, 51, 252. Well, that's as good a point as any to stop. You can check out some of the other videos and you'll find some more of these while loop items worked for you there. You have a few left here in the input testing loops that you can work through, or you may find a few of these worked in videos as well. So good luck, and I hope this helped with the input testing loops.